So just a few words about GerritForge Inc. If any of you don't know who is GerritForge, so first, this is actually our headquarters. We are a distributed company, and this is the place where we meet when we are in the US. We are based incorporated in California, Sunnyvale, but we have been contributing to Gerrit well before I was incorporating a company in California. So I originally built the company in the UK, then we moved here something like 6 years ago, right? So it's already a long time. So we have been contributing to Gerrit and JGit since 2012. However, before we were contributors of JGit and Git itself. So Gerrit was at the very beginning, but we already contributed to that. We got a huge presence into the Gerrit community. So Danny is the community manager. I'm a member of the engineering steering committee. I'm also one of the managers of the Gerrit release. So I'm one of the guys that's right to the mailing list that Gerrit has been released. And in GerritForge, we got 4 different Gerrit maintainers. 2 of them are also maintainers of JGit. And basically everyone in the company is contributing to Gerrit. With regards to what we do, actually there is something new to announce. So since December, we are also official partners of Google Cloud. This is because Gerrit is now officially available as Gerrit as a service on Google Cloud. So if any of you guys are using Google Cloud, they can just go to the marketplace and purchase Gerrit and have Gerrit working as a service in Google Cloud, which is great to see. And also last year we launched a new product that is called GHS. So GHS means Git at very high speed. What does it mean? It means that if you use Gerrit or if you use Git without Gerrit, using GHS, you can make your Git and Gerrit 100 times faster, and I'm not kidding, right? And why I'm talking about GHS? Because a lot of improvements that you see today about JGit and Gerrit, they're actually coming from the research work that we have been doing on GHS. So why is building GHS as a product, right? We say, oh, we can do a lot more in JGit, we can do a lot more in Gerrit. So a lot of findings and discoveries, we put it back into the open source community, right? And if you're interested in GHS, of course, reach Danny here or me during the day or even afterwards. So we are very active in the community, as you can see, GerritMeets. Those are the meetups, they are organized by Danny, and we are having typically monthly here in Sunnyvale, but we also do in other places. So we have been doing some of your locations, right, as well last year. And we also did in San Diego and also in Europe. We did one in Munich. And again, if you want to host one of the next meetups, be our guest, get in touch with Danny. We're more than happy to organize one.
How many times have you said Danny already?
Danny, it's you, right? And last but not least, JGit. Yeah, we have been working a lot on JGit in the past 12 months and even before that. And I believe this year, JGit is going to be the main driving force into more performance into Gerrit. So let's get started. Today's agenda. So first, when is the new version of Gerrit coming? So dates. So we'll talk about dates when you would expect Gerrit 3.12 and 3.13 coming. Then we'll see some detailed highlights, I would say, for Gerrit 3.12 because Gerrit 3.12 is not very far away. So it's there. We are going to see what you should expect there. Gerrit 3.13 as well, and then of course a little bit of brainstorming on what Gerrit 4.0 should look like, okay? So just a disclaimer, whatever you see here, this is a copy and paste from the roadmap of Gerrit Code Review. This is our roadmap. It means that this is what we believe that we can deliver, of course. It's subject to change and also is not a commitment, but it's a roadmap, right? And when we write the release notes, that's a commitment, right? But this is just, let's say, what you should expect. And I believe it's good for you to see in perspective what is coming on the horizon. Okay, so those are the dates. So you don't have the number of the day or the month just because I haven't published the release plan yet, right? But the release plan for Gerrit 3.12 should come by the end of this month, so you will know the exact day. But it's definitely going to be beginning of May. And Gerrit 3.13 is coming at the beginning of November of 2025. One thing that is very important, you will see from 3.12 onwards, Java 21 is going to be a mandatory requirement. It means that if you don't have Java 21, you won't be able to migrate to Gerrit 3.12. Up to now, you had the option to use Java 17 or Java 21, but from now on, it's going to be Java 21 only. Okay, high-level topics. So first, you will see in this presentation that basically I separate the topics in three pillars. One is Gerrit Core, one is Gerrit, one is plugins. And that's very important because when you use Gerrit, you don't use just the UI. You use the UI, use the Git protocol, and you also, I'm sure that you guys use lots of plugins, right? So it is important in the dropper, you don't see just Gerrit, but Gerrit with the ecosystem of components that make your Gerrit build work when you work in the office. So on the Gerrit Core, the main improvements are about security and compliance in Gerrit 3.12. So if you work in a large company, you will be really glad to see this one coming, just because of course you will have your manager say, when, I don't know, compliance with X509 signature will come into Gerrit. There we go, it's coming there. There are some usability improvements, we'll go to that. And very important, there is a bump of the H2 caches. We'll go into the details. On Gerrit, and this is going to be a common theme of Gerrit in 2025, speedometer, performance, performance, performance. Okay, so we want your Gerrit to become faster, and Gerrit is the engine that is driving your car, that is Gerrit, right? Of course, all the structure of the car needs to be reinforced to go at higher speed, but the engine needs to be able to go at higher speed. That's why as GerritForge, we invested a lot in that. So, and one thing that is very welcome to see, we are definitely going to do a lot of testing and a lot of scalability and tuning and benchmarking and share with you about ref table. How many of you guys know what is ref table? Raise your hand. No? We'll go into the details. I'm going to show you what is ref table because this is something that absolutely you want to adopt if your repo is big, right? If you have a small repo, okay. You can also leave the room, say performance is already fast, I don't need it. But if you have big projects with a lot of people and big repos, ref table is definitely going to be a good help. For instance, for you, Malvika, I know that your repos are very good, ref table. I believe I was speaking with Mark, right, about ref table something like 5 years ago. So Mark will be glad to see this coming, right? Plugins. So I believe some of you guys were ready, or maybe you already watched last month's presentation about the Owner's UI. So of course, all the goodies of the UI integration with the Owner's plugin that basically allows you to see at file level what is the approval status for different owners. And if you use Gerrit Analytics, that it basically extract data from your Gerrit repo and your changes is so much faster with 3.12, okay? Let's dig into some details. So first and foremost, Java 21. So I'm sorry if you were really attached to Java 11, Java 17, you need to wave goodbye. In 2025, they are not going to be supported anymore. And binary and source code, they're both going to be set at Java 21 level. So it means that really you need to plan these in advance. If you're working on premises, is maybe a little bit more difficult because you may need to bump a little bit your operating system requirements. If you use already a Docker-based setup, so much easier, right? Because basically the Docker distributions of Gerrit already come with Java 21 pre-embedded, okay? What are the benefits? First, in Java 21, you've got the ZGC algorithm. And if you're interested on a real-life story from Matthias Sohn about the KTS Gerrit talk, he was mentioning all the benefits in SAP when they moved to Java 21 and all the benefits of this garbage collector. This has been already published on YouTube. Of course, that's the link. We're going to publish the presentation. You will just click on the link and see more details. We will need also to do some slight upgrade on the native distribution. So it means that if you use the Docker-based distribution, you may look at the bumps also on the operating system level on the Docker images, okay? Secondly, X509 certification. So when you use Git, you can sign your commits also with a digital signature, right? And historically, whilst with native Git, you could use also your X509 certificate because in native Git, you could just use a utility that you configure. In Gerrit wasn't supported. So we plan to merge in Gerrit 3.12 and in Git the validation for the signature of the commits down with your company certificate, X409. And that's really good to see because it means that if your company maybe is large and maybe already uses X509, it means I don't have to manage GPG keys anymore. And I can reuse my existing identity for doing some signatures. What is more important, we are planning also to merge the ability to integrate with submit requirements. It means you could say, for instance, that a specific branch maybe needs commits or tags that need to be digitally signed for maybe making a release. You can make part of your submit requirements. So it means that you can make on a per project basis, but also on a per branch basis, right? And that's really cool if you work in a large company. Secondly, this is really big. So Matthias Sohn merged the bump of the H2 version of the persistent cache. So if you notice, there is a directory in Gerrit setup that is called caches, and in there are some files. And those files are basically H2 embedded database that Gerrit uses for storing some cache information that needs to be persistent. So in Gerrit 3.12, the version has been updated from H2v1 to H2v2, and this has been done for giving two big features. First is the ability to have some live snapshots or your caches. And this is really good if you're multi-site or if you're HA, right? Because it means that you can expand and add new nodes to your multi-site setup and bring your caches over without shutting down anything of the existing stuff. So a lot of improvements that you see there, they were made because SAP uses HA and GerritForge uses multi-site, and many of GerritForge customers are using multi-site as well. And this is going to make your ability to scale so much better, right? And second point, and this has been notified on the mailing list multiple times, H2v1 was suffering from a data corruption when the JVM was crashing, which is really, really unpleasant, because if you lose your H2 caches, rebuilding the H2 caches is very expensive. Just a warning, so H2v2 is not compatible with H2v1. So you will need either to use some utilities from the H2 database to migrate existing caches to v2, or to regenerate the v2 caches from scratch, okay? Regeneration is very expensive, especially the diff cache, so strongly recommended to do the migration, but of course, that is not automatic, it's not out of the box. You need to use a tool provided by the H2 database. Or if you want to jump on the boat and say, maybe I want to use something different from H2, then that could be maybe the right time to jump into a different backend for persistent caches. So if you're interested, next month we're going to talk Cache Chronicle Map that is so much faster than H2. Okay? The main difference between H2 and Cache Chronicle Map is that Cache Chronicle Map is using allocated cache files on disk. It's going at raw speed. So we moved the Gerrit Hub.io from H2 to Cache Chronicle Map 5 years ago. I will never go back to H2, absolutely, right? So let's continue. Usability improvements. This looks small, but it's very big to me. How many times you have seen the painful task of formatting your commit message? Oh my gosh, I needed to do it by hand. I always say, why can't we have just a format button? There we go, you got it in 3.12. So whenever you see your commit messages, it needs to be reformatted, you click format, there you go. And another thing that was really nice to see, you know that Gerrit allowed suggestions on everything, but not on a commit message. Now you can suggest also changes on the commit message, and then of course the author can just go click a button and apply the fixes there. Maybe one day we'll see that coming also to other products, right? They are not Gerrit, because commenting on commit message is so important, right? So why those features are not available there? Gerrit, you got it. And this is really very important. This is regarding to performance. I always love to say that Sean Pierce was telling us as maintainers and contributors that speed is so important, right? He would say speed is not a nice to have, speed is a feature, right? And in Gerrit 3.12, you see a lot of speed and performance improvements. So here we reused all the knowledge and all the improvements and all the research that we've done on GHS. GHS is our product, but of course we did a lot of research and we used that knowledge to improve JGit. And you will see first some massive improvement on the way that Gerrit does objects lookup in pack files. For instance, whenever you do clone, there is one phase that is very expensive. It's called search for reuse. That phase is going to be tens of times faster in Gerrit 3.12 because some JGit improvements. We improved a lot also when the repo is not in a perfect shape. The object lookups across multiple pack files is going to be so much faster. Here, there is basically a kind of preview of the multi-pack index capability. By Gerrit 3.12, it's going to be done on the fly in memory. And you will see in Gerrit 3.12 as 3.13 will got a more official multi-pack support. But last but not least, we have basically provided to the open source community the result of research that we did on the way to speed up bitmaps. So we analyzed the CPU utilization of the GC phase. How many of you guys do get GC on your repo? Raise your hand. Good. Is it fast or is it slow? Slow. And we did a lot of analysis on why it's slow. And the GC is using a lot of your cores except one phase, the bitmap. Because the bitmap needs to navigate a history, right? And the algorithm was doing a linear navigation. We saw, why do we need to do a linear navigation? Why can't we do a parallel navigation? Similar to maybe Zool does, right? Why don't you do speculative, right? Parallel. Maybe some of the stuff is not useful, but maybe some of the stuff is useful. And you can use all the power you've got. So we developed a new algorithm for doing the bitmap generation in parallel. And the results are mind-blowing. You will see that, it will say, wow, I've never seen such a speed of generated bitmap before. This is going to be yours in 3.12, okay? And last but not least, RefTable, okay? RefTable are going to be there and production ready.
Or don't do GC and just use GHS.
Or, yeah, another thing as well, yeah, GHS is the product that we built based on all this knowledge. So you say, I want to know all those tricks. Man, we are in the AI world, right? GHS is a tool that uses AI and knows everything about all this stuff and does all the optimization for you on the repo, right? If you're interested, go to that, of course. If you want to learn more about all the other optimization we did on Git, we actually presented in San Diego last year. So there is a YouTube link there, and you can go and watch out and see all the different details of all the things we improved. ONS plugin, so we already presented last month, but just to remind you that this is going to be officially supported on 3.12 as well, right? And for all details, basically the ONS plugin will have a lot of UI now, and that is going to give you a lot more visibility of who needs to approve some of the files, or what is your task in your change, what you need to do. And last but not least, analytics. So you guys, how many of you use analytics on the repo? How many of you guys do analytics on repos and changes? Do you do it? So I strongly recommend to start digging data because your repo contains so much information that could be useful to you, right? Even in understanding how people are using it. So the analytics had one problem before. It was slow, of course, because you have a lot of data to crunch. So we managed to improve, and when you do analytics, typically you want to understand how much data is in different branches, because many companies, including Android, but maybe also your company, uses branches for managing releases. So you want to understand how big is this release compared to the previous release. So analytics is able to get all the information in different branches and aggregate that together, right? But that was a little bit slow. In this version and in 3.12, so much faster, up to 1,000 times faster. If your repo has multiple branches, it's a different planet, right? Now a demo, right? And as I mentioned, because performance is a feature, was the best feature to show you? Performance, right? So let me show you first that I have a Gerrit 3.13 installed here because I haven't started the release process, but the release process will start from the 1st of March. So from the 1st of March, you can install this one on your test environment, not in production, please. It's going to be an RC0, right? But your test environment. So at the moment, it's called 3.11.1.551. The 551, it means that's 551 improvements over 3.11.1, okay? As you can see, I've got lots of changes here, and I've got it here installed. And in this specific demo, I want to show you how much faster is RefTable compared to the packet refs. And now let's go to RefTable. So how many of you knows how are refs organized in a repo? Good. So let's do a little recap. So far, you saw refs organized in this way, right? So you got a packet refs file, and this one contains basically just a text file, right? It contains all the refs with all the feature branches here, right? In this case, I just created some random feature branches. And these are called pack refs. but you also have a directory with all the loose refs, right? And as you know, this way was efficient or very inefficient? Very inefficient, because loose refs are, of course, occupying inodes on the file system, so very slow, and can actually clobber your file system because the file system will run out of file descriptors. Inode, sorry. But the packet refs, they were one big file with everything. So what happens if you need to remove one ref? You need to rewrite everything. That is very painful indeed, right? So it was not scalable. And to show you how it was not scalable, for instance, in this repo, I've got this repo is called, in this workspace, I've got two remotes. One is pointed to GerritMeets, right? This one. And I have a simple test file here, a test script. Sorry, not this one, that is called test changes. And I'm gonna call this one on origin. In this script, what it's doing is just simulating two users. They are pushing 10 changes to this repo. Let's have a look. Is it fast or slow? Let's have a look. I'm running it now. So it's creating these two clients. The clients are creating changes. As you can see, it's kind of clunky, right? But it's creating changes on this repo. And what's the problem? That every time that needs to create changes, look at this file. It's locking the file. You see the packrefs is constantly locked. And if you go to your production environment, I bet that if you go to that directory, you will see the lock file is always there. Say, why does it go away? Because it's constantly rewritten, right? And every time the packref needs to be rewritten as well. You see it took 18 seconds. So how ref table is different. So I've got the same repo, exactly the same one. And so you will see that I'm going to use exactly the same client. But this one is configured with ref table. And the difference is that if you go on the config, you will see that in this case, it's written that ref storage is ref table. So how is different ref table? There is no packet refs, but there is a directory. It's called ref table. And in this one, you've got some tables. Those are the ref tables. And their organization is pretty similar to the pack files themselves, right? So it's basically a binary format, not a text format, so a lot faster. And JGit can read partial and parts of the file when they need to do a lookup of a ref. So instead of loading everything, I can go straight there and read that one. So even if your repo has millions of refs, it's so much faster just reading a single one. And you've got a file that, of course, give you the transactionality for making sure that you can add ref table in a transactional way and have a consistent snapshot. It's called table list, contain the list of tables there. This has been developed by Sean Pierce. There was the Gerrit project founder, and Sean Pierce was one of the top contributors of the Git project itself. Sean Pierce passed away many years ago, so we continued the Gerrit project, of course, as a community, but I'm really proud to say that ref table was coming from his mind. It was a genius, right? And then it was done for Google for over 10 years, used in production, and Han Wen, that was was actually the project leader of Gerrit, moved to the open source a few years ago. But it's never been used as production ready in Gerrit since now. And now in Gerrit 3.12 you can use it. So if I do the same test here, but I'm using the origin ref table, that's basically my client, but just pointing to ref table as a remote, right? You see that if you will notice already visually, it's a lot snappier in creating the changes. And then we will see the results, how much faster it is compared to what it was before. And I was chatting with Martin, my son, before. We were just doing a little bit of maths to understand how much faster it is. 15 compared to 19, right? So 4 seconds faster on this simple test. And bear in mind, I haven't changed anything. No changes in Gerrit config, no changes on the client, no changes on anything else, just set ref table in the format. And to be at least 25% faster tomorrow just by flipping to ref table, raise your hand if you want to. Why not? Yeah, everything, absolutely. Okay, so now I will give the word to Matthias, and Matthias can say also what is coming from Kate's Gerrit perspective. Matthias, do you want to share?
Okay, so I will talk just 2 slides about what's cooking at SAP, so what we plan to do this year and beyond. So we are working on Kubernetes deployment of Gerrit. So we're working on support for shared indexes. This This means we'll have to push more specialized Gerrit pods. So we plan to put the indexing into a specialized pod, also replication. We will introduce tenant separation so that you can use one Gerrit deployment to serve multiple customers, for example. And in the GS operator, we're working on introducing a maintenance container to run GitGC, automated repairs and other stuff. We will further automate the schema upgrades. So the goal is to fully automate that. And we will also look into autoscaling. Gerrit and JGit. In Gerrit, we were also already working on improving remixing performance. We have some further ideas how to further improve that. We will introduce support for more than 2 primary pods in the HA setup. We plan to update to JGit 12 and also update to JGit Master again. We will introduce OAuth authentication for our own IDP, and not just for the UI, but also for REST and Git. And in JGit, we're also working on ref table support to make it improve it. We plan to do implement OAuth and certificate authentication client-side in JGit. And a more far-reaching goal is to use Panama foreign memory access to use memory mapping to access pack files, which should improve performance and reduce memory consumption.
Okay, thank you very much, Matthias. What's next for 2025? So first, Gerrit 3.13. Again, we're going to the 3 parts, 3 pillars. On Gerrit Core, we want to help you making a better setup of Gerrit. So we'll make more official and mainstream the use of a headless Gerrit. Do you know what is a headless Gerrit? So I believe Matthias touched in one of these past presentations, but basically when you use Gerrit, typically use Gerrit that contains everything, contains the UI and contains the Git protocol. However, that's not ideal because it's very hard to do some JVM settings on the garbage collection. They are as reactive as possible for the UI, but as performant as possible in terms of throughput for the protocol. And in theory, you could have done it already now, but it's not documented, it's not easy, and it's not packaged that way. So we're going to package and make it very easy for you to follow how to make a setup where actually you don't have one JVM, but you have a Gerrit that just serves the UI and a headless Gerrit that serves protocol and REST API. And that is really key because it allows you to do 2 big things. First, to scale them differently, right? Maybe you need different scalability requirements for the Git protocol and for the UI. And also maybe make it more elastic. Maybe on the Git protocol, you need more elastic for serving the CI/CD traffic, maybe coming from Zool, right? Or maybe on the UI, say, why Zool can maybe give you some big peaks of traffic. Actually, that happens, right? We were just discussing, we did a rollout with a big client. It was a couple of weeks ago. And yeah, also Jace was involved in the Zool side, right? But the people are not spiky at all, right? If you have a team of 1,000 people, there's still those 1,000 people. It's not that, I don't know, in one hour it's going to be 1 million people. But CI, no, it could be actually this level, right? So you will be able to scale them differently. And the second point, usability. So we hear what you're saying and we listen to you. And some of the people are managing large repo, and some of the changes on large repos have a lot of files. Who likes to go and scroll up and down to find the files they're looking for? Wow, it's so painful, right? So we will allow the people to just filter, right? I'm looking for all the Java files in this change. Can you just show me all the Java files? Or if you use the owner, I just want to see the files that I'm owning at the moment and my review is needed. So we will allow basically to introduce filtering in the change list. Very easy UI stuff, but very useful. With regards to JGit, another big bunch of performance improvements. So we will merge the multi-pack index support that actually started as activity of the hackathon. So we were touched a little bit about the performance on looking for objects in multiple packs. But in Gerrit 3.13, you will be able to read in Gerrit and in Gerrit a multi-pack index that has been written by Sigit. You know, if you use Sigit, the command line, you can already create a multi-pack index file. But Gerrit doesn't use it. In Gerrit 3.13, Gerrit will be able to use it. We are going to improve a lot more the performance of pushes. Why I say pushes? Because again, if you use tools like Zool, right? Zool, what it's doing is taking different changes, trying to cherry pick in a way that is going to be, let's say, compatible and make it build green, but creates a lot of, let's say, traffic also on the push side. The CI is not just doing clones, it's doing also pushes. And you want to scale with that one. You want to make sure that your repo can scale as quickly as your CI/CD cluster. And because of that, of course, we needed to improve a lot the concurrency on logs. So how many times you've seen log failure when pushing something on Gerrit? You don't want to see that anymore. So Gerrit 3.13 will give you some relief on that, okay? And if you're using multi-site, and as you have seen also Matthias was talking about scalability of multiple nodes, we are going to make changes that allow your specific multi-site setup to grow dynamically, right? So we'll introduce the ability for replication plugin to do dynamic provision on your replication endpoints, of course in a secure way, right? And that will be used for your Gerrit multi-site. So multi-site will be able to scale dynamically. So the H2 V2 of course will help because whenever you provision a new node, then you will be able to reuse the indexes and store caches, but also you will be able to provision the new node automatically as a replication endpoint, okay? Like 3.13 features, of course this is subject to change. I know there will be a lot more, but what's already in the menu is not bad. But we want to see beyond that, right? So the point is, okay, Luca, you're going to tell me in 2025, but many times in the Gerrit User Summit, there was what GerritForge will look like, right? And actually, as maintainers, we were asking ourselves, what does it look like, the future, 2026, 27, 28, 2030, what Gerrit will look like? So this is, again, our view, and in this case, personally, my view, but I invited other maintainers. Nasser, Matthias, can you hear me?
Yeah, I hear you.
Okay, sounds good. Okay, so let's continue the presentation there. As I was saying, this is my view, but then of course we'll go into a more Q&A session where you guys can tell us what do you believe GerritForge will do or should do, and also we'll ask Matthias, we'll ask Nasser. So my view is that first, Gerrit itself needs to be decoupled a lot more. So it means many times Gerrit could be useful even without a review UI. I remember that when I started introducing Gerrit to clients over now 12 years ago, people were saying, actually, you know what I really like about Gerrit is the security model, is the performance, right? Is the management, is the ease of use, the stability, right? But maybe I want to use a different code review system. Can I just use Gerrit just as a Git server? And so far, the fact that it's called Gerrit, sometimes it is an impediment. That's a real life story. There was some of the clients talking to us by saying, can you guys change the name of Gerrit? Because my managers, they don't understand that Gerrit is Git. They say, why don't you stop using Gerrit, use Git? I say, no, Gerrit is Git. Yeah? So we want to make sure that Gerrit can also be packaged in a way that if I want, I can just use it as a JGit server. So I like the code review API. I like the ACLs. I like the security. I like the compliance. I like the ex-provenance verification of signatures. But can I just use the UI? So we want to decouple in making sure that Gerrit is packaged in a way where if you want to use the UI, but if you want, you don't use the UI. If you want to use the code review, but if you don't want, you just use all the power of JGit, right? So basically, breaking down Gerrit into a JGit server, a code review API, and the Gerrit code review UI in a way that you can build them together, use them together out of the box as it is today. But if you want to, you can just use JGit server. At the moment, JGit is packaged differently because if you want, you can use JGit, but only as a client. If I want to use JGit as a server, at the moment, there is no packaging for it, right? Second theme is, if you follow me, if you use a Gerrit server, why I can't use Gerrit server multi-site now? So you know that if I don't use Gerrit and I use another Git server, nobody provides multi-site out of the box in the open source, right? Why can't I use just Gerrit server multi-site? And use it maybe together with my non-Gerrit code review. Imagine, I'm sure that you guys use also GitLab or GitHub or you name it, right? Why can't I use Gerrit server just maybe for serving all the CI traffic in multi-site? Or if my company is distributed, I've got people connected from, I don't know, Forest, maybe they can use Gerrit in this way from their location, right? This is something that, again, if you do a little bit of hacking, you can do it as well, but it's not available out of the box, yeah? More, and this is actually has been done already as a prototype, why can't I use Gerrit for doing a code review that is not based on changes, but is based on branches? What does it mean? So if you, of course, if you use GitHub or GitLab or you name it, you have seen that they have a different code review lifecycle that is not based on changes or reviewing commits, but reviewing topic branches. And I don't know how many people knows that actually you could do it if you want in Gerrit. It's just a problem of user interface. Because if you think about it, if you have a feature branch, you want to do the review of the feature branch, what do? Do your feature branch, then you review the merge of the feature branch, and there you go. You got already the review of a merge request. So it is possible already from the point of view of the API, but it's not accessible in terms of user interface. So Dave Borowitz, that was the project leader of Gerrit Code Review until 2019, came up with a very interesting prototype where it was showing different UI where you could actually have native support for branches together with changes, in a way that if you want, you can do branch review. If you want, you can do change review using the same user experience, which is really good to see. So we do believe that once you decouple the user interface of Gerrit, the REST API in terms of code review API and the Gerrit server, you could use maybe this prototype and as production ready, right? In a way that if your company wants to use Gerrit, with teams that haven't used Gerrit before, they say, I know you don't know how to use Gerrit. Do you know pull requests? Yes, you can use Gerrit now, straight away. And that is a big benefit because it's very expensive for companies managing 3 million tools, right? And in my experience, all the companies that tried to get rid of Gerrit, they ended up with Gerrit plus something else, right? Because you can't replace Gerrit. You can't replace this level of functionality and performance with anything else. So why don't you use them together? And have Gerrit supporting also branch reviews. And AI, so this is something that is already out there. So already in Gerrit today, as you have seen, is possible to use some AI tools that provides code generation, code review, code suggestions, and so on. However, at the moment, they're just external plugins. And they've got difficulties integrated with Gerrit because sometimes the REST API, the code review APIs, they don't have the right entry points for those plugins to provide inputs. So we have been contributing, for instance, to the ChatGPT plugin for Gerrit Code Review. There was also a presentation that was done already. So if you go to our YouTube channel, you will see that. But it was a bit tricky to do it. So we do see GerritForge with a lot more input in the code review API to allow the integration with your AI tools, whatever, let's say, you use, not necessarily ChatGPT or Llama or whatever, you name it, okay? We see that growing in GerritForge. And then let's go to the brainstorming. So first, if anything that you've seen before is interesting for you, but you want to see it maybe before 2026, 2027, 2030, and so on, talk to us. Because as GerritForge, we have some sort of accelerator program that's within this way for some of the features. But I would like now also to stop sharing and give the word to the other maintainers to understand, and also to you guys, what do you guys think that GerritForge should do? So let me stop presenting. There we go. And yeah, maybe some Matthias or Nasser. Do you want to give your view of GerritForge or add anything to the roadmap that we presented so far?
I was going to let Matthias go first, but yeah, No, I mean, I think I'm excited about some of those ideas for sure. So you know, I think at a high level, I don't know that I have a favorite that I would pick in there, but certainly, you know, the idea of being able to have, you know, more granular Gerrit and the last one you were talking about with, or not last one, second last one, branch-based reviews, making Gerrit more approachable, right, to people coming from a GitHub world and a GitHub model. I think would be helpful. Not necessarily as something that's you know, has really been a huge problem for existing Gerrit users, but I do think it's could help overall with Gerrit as a product offering.
Yeah, sorry, I didn't introduce Nasser, but Nasser is one of the historical maintainers of Gerrit Code Review. And I believe once I showed some pictures of the very first members of the Gerrit community, Danny couldn't recognize Nasser because Nasser was so young that Danny said, "Who is this guy?" I said, "It's Nasser."
I'm gonna add, I cannot recognize Nasser month from month. Like, dude, you changed too much.
So Nasser is the leader of the Gerrit project in Qualcomm, and it's based in Boulder, right, Colorado.
Yes.
Matthias, what is your view of GerritForge 0? Do you want to say something?
I hope that we will then have finally memory mapped file access to pack files in JGit. But this will be quite a lot of work because it will break a couple of APIs. So we can only do this in JGit 8, I think.
Yep, no, absolutely. Anyone from the room? What do you think about GerritForge 0? Yeah.
I'm curious if anybody's interested in LFS, better LFS support. Our team specifically struggles with we're using submodules to store large data files, gigabytes of data files, and that causes no end of UX issues. And so I know that the existing LFS plugin is considered do not use, last I checked. So I'm curious if there's any interest in updating that.
So my first answer is actually a question. Why do you need LFS if you go partial clone, if you go supports for large, let's say, blobs into your repo, and the ability also to do, let's say, sparse checkouts? Why would you stick with LFS that is a kind of, let's say, all-stack technology compared to what Git can give you natively for support for large files?
Great point. I guess our developers are used to just fetching the full repo, and so if they get impacted by large pushes in like separate branches, if they pull they would just want to work on master branch and some other branch got updated, everybody would pay that cost, and so LFS ideally would avoid that because you only pay the cost when you're checking out the specific branch that gets it. So we'd have probably. I need to understand the use case you're describing more, and then we'd have to educate our users to use that.
Yeah, so with regards to the problem that you were mentioning, so basically you're impacted by people pushing in other branches. There are actually plugins that allows you to be protected against that. So for instance, there is a plugin that I developed, it's called Git REST Filter. That one allows to manage a very, very fine-grained visibility at Git protocol level of what you're impacted from. So in a way that your Git client will actually not even know that those branches exist, right? It will not be impacted by fetching anything related to them. And for instance, with that specific plugin, we have seen some huge performance improvements at Git protocol level because basically you don't transfer all that data. So in that case, you don't even need LFS. But just to give you one example of why, let's say, using the capabilities of sorry?
Yes, you could.
Okay, so why using the capabilities of large files in the Git protocol is superior? Because if you do LFS, every time that you want to get rid of large files in the repo, you need to rewrite the history, which is a big pain in the neck, right? Whilst with, let's say, partial clones and with, let's say, the filtering of large blobs, actually it's your decision. You could have some default parameters that says, listen, I don't want to fetch anything that is over, let's say, 100 megabytes, unless I want to. Right? And if you work, for instance, in a mono repo, where most likely you're impacted by the problem, you may say, listen, I want to check out, I want to fetch everything that is not over, let's say, 100 megabytes, If you need the client will ask for it on demand automatically. And then secondly, I will really want just to do a sparse checkout of this specific folder and not everything, right? That allows your client to be so much faster, and this is already supported out of the box in the Git protocol. The second thing, whenever you manage large files, the problem is how do you then load those large files? You got problems related to replication, problems related to security, but problems related to the transport. If you use the native Git protocol, Google has implemented also the CDN support into the protocol. It means that if you use the Git native protocol, you could get imagine that you really want a very large file of 1 gigabyte. With the CDN support, actually that gigabytes is coming from maybe 50 different places that will give you a little parts of that gigabytes of that pack file. It's so much faster. So there was a discussion about LFS in the Git community. And I remember I was present in that Git merge, and basically the Git community would say, what shall we do? Should we continue investing in LFS, or shall we make the Git protocol, let's say, more approachable and more scalable to large files? And I remember the overall audience was saying, why should you keep on going on the wrong path, right?
I guess what we're trying to say is LFS is essentially deprecated, is what you're trying to say.
It is still, so it's not deprecated officially, so it is the legacy way of managing large files. And I believe the main reason why you would like to have support in Gerrit sometimes is because many people in the company already use it, right? So let's clarify. You don't need the LFS plugin in Gerrit for using LFS. LFS is something that is between your client and your LFS backends. So we got people using Gerrit, even very old version of Gerrit, with Git LFS, and Gerrit is absolutely unaware of it, right? So the LFS plugin currently is deprecated. We have no plans to, let's say, work on it at the moment. But of course, if that is a specific use case you got, then talk to us and we'll see, let's say, if we can do maybe on an ad hoc basis. But as a community, we don't really feel that much, right, going there that way.
Next one. We've got a bunch.
Sorry.
I need to keep it moving.
Real kind of follow up to that though. So Luca, who is there somebody in the community who's been looking at the host side challenges with partial clone, right? Because while clients, maybe don't have to download that large file, you still have to store it on the host side. Right, as an alternative to LFS, right? So if I'm using partial clone, that helps me as a client. But in Gerrit, we still have to store, multi-gigabyte blob, perhaps.
Yeah, but do you see that as a problem?
It may not work well for everyone. So I was, I'm saying, do we expect that to work fine in Gerrit and JKit?
I believe maybe it's more a question for Matthias with regards to JKit. So with Gerrit, there is actually no problems at all, right? Because you don't see that level. With regards to JKit, I believe maybe Matthias is related to the work that you are planning to do with regards to...
Yeah, one point is that currently JKit, when you load objects from pack files, it's first reading the pack file segments it needs, the pages it needs, and then it's copying it to byte arrays in memory, and then it's parsing it and so on, and unzipping it, and then parsing the objects. And this is quite some overhead. And if we do that work, which I mentioned, to replace that by using Panama for in-memory access, we can directly memory map pack files into memory, and this should help a lot. Another issue is with large blobs is that, of course, you need to store them. So if that's the traditional file system, you may also hit limits at some point. As far as I know, Google is using a distributed file system so that they can horizontally scale the file system itself.
Yeah, with regards to storage of pack files, for instance, if you remember, Nasser, I believe you were there as well when I presented the Cassandra-based backend for pack file storage. And with Cassandra-based backend, basically is unlimited, right? You know how Cassandra, how many of you knows Cassandra? Cassandra is basically a distributed file system, right? It's actually a distributed database where basically I demoed how you could use as a storage for pack files. And the performance, they were absolutely great. So because in theory, people will say, okay, but that storage is very slow. Now, because Cassandra is basically using massive techniques of caching, then first, the information you're fetching is most likely to be in memory in one of the Cassandra cluster, and then you get a raw speed from that point of view. I believe the issue is more, what about the bandwidth, right? And that's why I was mentioning the CDN. Because, of course, if you're serving everything from the Git server, from the Gerrit server, then of course you would say, yeah, but you're using all that bandwidth towards the Gerrit server, then you're slowing down the UI. But think about a future where maybe you will have GerritForge 0, where actually the Gerrit UI will just be the UI, right? And there will be a completely different cluster for the JGit protocol. And I believe maybe we could, let's say, ask Google also to contribute a little bit of their CDN implementation of the JGit backend. So because with regards to Google, Google has exactly the same problem, right? Because when they get some massive downloads of the Android code base. And in that case, the way they do is basically they have some already pre-configured, let's call pack files, that contains already the 99.9% of what people download anyway. And they transfer towards the CDN in a way that doesn't really get from the Gerrit server. So I believe in a future where Gerrit and JGit is going to be two different things, really separate and different JVMs, and we'll have a different scaling. And maybe a different backend, right? Gerrit will be based on file system, but maybe JGit will be based on a Cassandra based, right? And I believe some of the clients actually asked us directly by saying, can you do Cassandra backend? I say, we did a prototype, and of course, it was open source. And if Matthias, I believe you saw the prototype, right, of the Cassandra-based backend.
Yeah. I mean, Google started that API, so the API is in the open source version of JGit. So it's called DFS repository, distributed file system repository, and Google has an implementation on their distributed file system, but since that's proprietary, their implementation is not open source.
Yeah, so in that, but let's say the one that I demoed a few years ago, it was absolutely open source. So it means that
this was in Cassandra.
Yeah, it's still there. So Nasser, if you guys are interested, maybe we can add to the 4.0 slides, right?
All right.
Yeah, it could be.
Yeah.
Okay, so is JGit cert authentication SSH certificates or X509?
Okay, so this is more for Matthias, right? The one that you mentioned in your slides.
I didn't understand what Dani was saying.
It was saying if the authentication, so you know the certificate authentication that you were talking about in your slides, it is based on X509 certificates.
Yes, correct.
Okay.
Are X509 signatures generated by Gerrit or developers?
The signatures are generated by developers because they are typically your smart cards or your identity. And then Gerrit will do the validation of those ones.
I'm gonna
the signatures are created on the client side.
Exactly, and they have to be created on the client side.
I'm gonna come back to this one because it's gonna start another discussion.
Maybe a quick follow up on that, though, real quick. Matthias, would that lead to being able to maybe do dynamic credential generation?
How is that related?
If you could do a certificate-based authentication in that way, similar to I think what GitHub has available through providers like HashiCorp Vault.
Yeah, I mean, typically a client certificate-based authentication is used in companies which already have an infrastructure to distribute those certificates to their employees.
Cool. Okay.
And
all right.
Based on that, you could also of course, also get information about those users. So, but I didn't think into that in detail about that yet.
All right. Rather quick one, I think. Will Gerrit provide any tool to migrate between H2 versions?
I believe I can answer that once. I believe H2 already has those tools. And in Matthias' change, Matthias also pointed to that tool. So if H2 already has the tool, why should we write yet another one?
Exactly. Does RefTable also optimize space on disk?
Sorry?
Does RefTable also optimize space on disk?
I believe so, because because it's binary. So, and from what I've seen, we did a lot of performance testing in RefTable versus packet refs, you spend a lot of time in doing the binary to ASCII conversion because that file is getting read and written so many times that having been binary.
You find some, if you're interested to get some numbers, just read the specification of the ref table. It has some data about how much it saves space.
Yep.
Last few ones, two or three. Apart from Google, is there any other company using ref tables? I assume they mean in production.
In production, I believe that. So the problem was that the implementation, the production-ready implementation, was not open source. Was the Google one. Then Han Wen wrote the implementation for Gerrit, and SAP and us, we are working as GerritForge. We're working very hard to make sure that it's fully production ready end to end. I think in terms of the code, it is.
Which we should, what we should also add is that Sigit supports ref tables since 2.45.
Yes, but honestly, use it with Gerrit and not Sigit yet, because I would say that in all the tests we've done, I've never seen a single repo corruption, right? We've seen issues, yes, we are fixing them. And Matthias is working together with us in finding the right way to fix it. And actually, I have to say to Han Wen, that was the one who implemented the open source part, the bugs that were in Gerrit and not in Gerrit, but we fixed the one in Gerrit, right, in master, right, for with regards to ref table. However, in our test of Gerrit with ref table, in Sigit, use Sigit to read ref table, don't use it to write it yet, because I found problems in the lock system when using Sigit, it was locking the wrong way and not according to the specifications. And when I tried to do concurrency between Gerrit and Sigit, Sigit corrupted the ref table. So I believe at Sigit level,
did you report that to the Sigit project?
I believe it's a Sigit problem. I need to report. I want to write a very specific use case, right? A very specific test case. Because if I report, I had a random corruption, I say, okay, could be anything. If I say, those are the instructions, those are the minimal instructions to get it corrupted, and that's the piece of code, and maybe that's my fix, that is going to be much easier to get it merged.
You need to talk to Patrick Steinweg, I think, from GitLab. He's working on that.
Yep.
I've not been super involved in the ref table stuff, but one thing I really liked about how we've been working together on this is how every change that we're doing, we're load testing it with our Gatling tests. So we're really able to really say if we're improving things and performance-wise, if what we're doing really improves performance or not.
And we are measuring end-to-end, because many benchmark on ref table you see, they're based on the API utilization, which is good, but doesn't give you the end-to-end view. The one that you've seen, for instance, today was really end-to-end, right? From a client perspective, if I enable ref table, what do I see? And for instance, in the case of client, I can just push it 25% faster, which is really good to see, right?
I mean, for Gerrit, the main bottleneck with the traditional storage format is the contention on the pack-rest file.
Yep, exactly. That's why you put two clients, for showing that you got a lot less contention.
You should use 20 clients, then you will see the difference.
Yeah, but my laptop doesn't allow me. But yeah, no, we did actually, you know that Tony did some load testing. It was using a client with 128 CPUs, and he saw a big difference. But something like hundreds of times faster.
That's what I was referring to.
With the ref table, the data corruption with the multi-site, is it going to be, because with the ref table, there is no data corruption?
No, so when I was mentioning the data corruption, it's because we did the testing of accessing ref table read-write from Gerrit and Sigit.
Okay.
The Gerrit code base has been written years ago and has been very well tested and used. The Sigit is brand new. So Patrick from GitLab just finished a few months ago his Sigit implementation. There are still issues. So it's not managing deletion correctly. So it's not managing the lock correctly. I believe there could be some bugs as well on the serialization. But this is related to native Git. So let's make an example. If you use GitLab today, maybe it's not the right time to use ref table yet. But if you use Gerrit and Gerrit, you'll be able to use ref table in production, and you're not going to get corruption.
We are seeing some replication issues with multi-site. The order of commits, there is one I reported for the deletion that we saw the problem with the 3 nodes.
Yep.
And there are more problems we are seeing. So Is there anything you want to talk about?
Yeah, that was pull replication. So in pull replication, basically there are, how many of you guys know pull replication? A little bit. So pull replication, differently from push replication, is able to get replication through multiple channels, right? If you use push replication, you just see a git push, that's replication. With pull replication, to achieve thousand times faster replication is using 3 ways. It's using the git fetch, of course. Actually, we should call it fetch replication, a pull replication. It uses git fetch. Git fetch is faster than git push, but still takes a few seconds. And uses also a REST API synchronous replication, and uses as a third way a broker, right? When you do deletion, the deletion of tags or refs is a basically non-fast forward operation. It means that it's not a series of evolution of a branch, but it's a kind of interruption, right? And basically in the pull replication, it was using deletion and creations using the REST API synchronous. You know, there's a good and the bad with synchronous. The good is that it's fast, low latency. The bad is that the order can change. Yeah, because if you go multiple nodes and multiple clients to do things synchronously, they can go in different orders, right? And if you have the same ref force push 3 times, think about 3 pushes done in different order. You get a different result. So that's the main problem, right? The pull replication. I believe we are going to introduce definitely some configuration that allows to say, listen, for these specific refs or these specific operations, even if you could do the synchronous, please go asynchronous. If you go asynchronous, there is always a queue, and the queue keeps the order. And then if you make sure that the non-fast forward push operation happens always in the right order, then you don't have a problem anymore. I know that you guys in SAP, you plan to use pull replication, right? Matthias?
Yes, and we also plan to combine it with a message broker.
Yeah, exactly. If you use it with message broker, you don't have this problem. Because if you always do pull replication via message broker, the message broker keeps the order. And then also in case of force pushes, you will still execute the force pushes always in the same order. Do we still an issue with retries? Because imagine you got 3 pushes and the middle one is failing, you go in retry mode. You need to be sure to put in retry not just the failed one, but all the subsequent.
Still force pushes.
Yeah, force pushes. If they are regular pushes, you never had this problem. In force pushes, of course. You need to make sure that also the other force pushes, they go and retry even if they haven't been tried before. With regular pushes, you don't have this problem. But with force pushes, what force pushes, I mean creation and deletion are sort of non-fast forward. So if you create a branch, you delete a branch, create a branch, you delete a branch, you create a tag, delete a tag is the same thing. But if you create a new commit, you never have this problem because you always make sure that your prerequisites are satisfied, and that works, right? Just one thing, so I want to remind you that there is going to be another Gerrit Meet next month. And because there's been already a lot of discussions on the mailing list because of the H2 corruptions, A2 migrations, H2 performance, and I'm sure if you use that H2 backend, you already experience sometimes that Gerrit freezes completely because sometimes H2 needs to reorganize itself, or maybe your Gerrit starts a pruning phase, and whenever you do pruning, the H2 caches, they block your entire Gerrit instance. You may be interested in next month talk about Cache Chronicle Map. Cache Chronicle Map is a different backend. Sorry?
It should be also a matter of the past with H2 version 2 because it's multi-threaded.
Oh yeah, that's a good thing, of course.
Actually, sorry, on this, we're going to be presenting Cache Chronicle Map, but I'd love if then someone else wanted to present H2. Like,
H2v2, why not?
Nothing against that. Yeah. If you guys want to talk about H2, more than welcome.
Yep.
Let me know. We'll stick you.
So
as well.
next month we are going to present our experience with Cache Chronicle Map, right? Cache Chronicle Map is basically different from H2 because it's not a database, but it's just basically a file pre-allocated with direct index, direct access.
Don't give away too much. Huh?
Anyway, so if you're interested, come and join next month, right? And of course, yeah, so Matthias, if you want to also share your experience with H2v2, that was going to be a good thing, right? So we're going to show what a Cache Chronicle Map can provide and also what H2v2 can provide in terms of benefits, okay?
All right. Thanks, everyone.
Sounds good. And thank you,
Bye,
Matthias.
bye.
Thank you, Nasser.
Stop.
Bye bye. Enjoy the rest of the
Bye.
day. Take care.